You are listening to The Vocal Technologist. Spoken tech for your ears.
I was thinking about the sheer volume of data being generated today, and it really feels like we're not just building systems anymore.
Oh, definitely.
We're managing these, sprawling digital ecosystems, and every organization is getting squeezed between two forces, right? The pressure to slash infrastructure costs.
Always.
And this absolute requirement to build smarter AI-enabled systems. It's the classic tech bind.
It is.
So welcome back to Product Thursdays on The Vocal Technologist. This is where we try to, cut through all of that and really focus on the technical shifts that matter in data products right now. We're here to pull out the most actionable stuff for you.
Exactly. And today, we're zeroing in on two, what I call non-negotiable strategic pillars. First, we're going to unpack some massive, really tangible cost savings in infrastructure. We have some numbers that are, well, they're jaw-dropping.
Okay.
And second, we're looking at the big architectural shift that you need to make to bring AI agents safely into your data stack. And just to be clear for everyone listening, we're not talking in generalities today. We're all about concrete facts, strategic context, and those little technical nuggets that, actually move the needle.
Okay, let's jump right into the money then, because some of these numbers are, as you said, pretty dramatic. I want to start with maybe the biggest cost-slashing example we've seen lately, and it's with Apache Kafka, which is, it's the heart of almost every modern company.
It is the central nervous system.
So I'm talking about Kafka's KIPI 1150. The diskless topics. We saw some benchmarks on Avon where they were sustaining 1 gigabyte per second ingest.
And 3 gigabytes per second egress.
Right. Across 3 different availability zones using only 6 nodes. And the CPU is just coasting, under 30%. That alone is pretty efficient.
But here's where it gets really, truly revolutionary. That one architectural change moving to diskless replication, it resulted in over a 94% infrastructure cost reduction.
Wait, say that again?
94%. So think about this. They dropped the annual infrastructure spend for a typical workload from roughly $3.3 million
Wow.
down to under $288,000. That's not just saving money. That's freeing up an entire department's budget to go build something new.
Okay, hold on. A 94% saving on a core component like Kafka. That just sounds almost too good to be true. There has to be a catch. What are the trade-offs? Am I re-architecting my entire monitoring stack for this?
That's the beauty of it. It's surprisingly clean. The trade-offs are really minimal.
Yeah.
You get a minor increase in cross-AZ metadata traffic and a slightly bigger JVM heap size, but honestly, that's just noise compared to the massive savings you get from not needing all that persistent disk and replication.
Yeah. So you're just challenging the old assumption that Kafka has to write everything to disk all the time.
Exactly. It's just the durability guarantees slightly, but the financial upside is just enormous.
That one fact should be sending shockwaves through every data engineering team listening right now. So while we're on storage, let's talk about S3. It's supposed to be cheap, but it can become this silent budget killer, can it? Especially for Delta Lakes.
Oh, absolutely. Proper S3 configuration is probably the best cost prevention measure you can take. A couple of pitfalls we see all the time. First, enabling object versioning when you don't absolutely need it. You've just doubled your storage costs instantly.
Right.
Another one is getting too aggressive with storage tiers, moving active files to infrequent access tiers, thinking you're saving money, but then you get hit with these huge hidden retrieval fees.
And the one that surprised me was the data transfer through NAT gateways. I feel like that's just an assumed piece of infrastructure, but it could be a huge drain.
A massive drain. Especially for distributed jobs. If your workers are pulling data from S3, but they're routed through a high-cost NAT gateway instead of a VPC endpoint, those data transfer bills just skyrocket. It's a simple configuration mistake with a huge financial penalty.
Speaking of storage, there's this old-school debate that's kind of resurfacing. Cloud cold storage versus physical tape. For really massive archives.
Yeah, and this is critical for any company with long-term regulatory burdens. We looked at the numbers. Let's say you're managing 10 petabytes of archival data. You're barely touching it, maybe 2.5% access per month over 20 years. In the cloud, that could easily run you about $6.58 million.
Okay, that's a huge lifetime cost.
It is, but the contrast is stark. A modern tape-backed object storage solution brings the total cost of ownership down to $4.11 million for that same 20-year period.
So tape is still winning for truly cold data.
For data that is genuinely cold, yeah. It just proves you have to be really honest about how hot your cold data actually is.
That's a great lesson. Okay, one more on the optimization front. A case study from Flipkart that shows good old-fashioned techniques still matters.
This one is a masterclass. They had this huge Spark ETL job, 7 terabytes of data, and it was consistently taking over 35 hours to run.
A day and a half. Ouch.
Exactly. Well, with some focused data engineering, they cut that runtime by 36%, down to a much more predictable 20 to 22 hours.
And how they do it, just throw more machines at it.
No, that's the thing. It was all technique. They did aggressive repartitioning, increased parallelism, and crucially, they used the adaptive query execution, the AQE for dynamic skew handling.
Ah, the skew handling. For anyone who's spent hours staring at Spark logs, that's the magic right there, isn't it?
It's the enemy of parallelism, right?
No.
One task gets stuck with all the data, and the whole job just waits. AQE spots those skewed partitions on the fly and breaks them up. That, plus some other tunings like using off-heap memory, just eliminated all their common out-of-memory errors and straggler tasks.
It's proof that tuning your fundamentals can literally cut a day off your processing time.
Absolutely.
So it seems like smart resource management is key. But you know, that drive for efficiency can sometimes lead to architectural knots, which kind of brings us to our next topic, foundational architectural principles and maybe challenging some old dogmas, like duplication.
Ah, yes. The sacred rule of DRY, don't repeat yourself. We're all taught to fear duplication. But in a modern data mesh, that fear can actually lead to over-abstraction and shared dependencies that are, frankly, way more dangerous.
Okay, but I have to push back a little. If I start duplicating data models and business logic all over the place, aren't I just creating a new kind of maintenance hell? What stops that from just spiraling out of control?
That's the key. It's controlled duplication. The idea is you only centralize the truly universal stuff, like core utilities and governance rules. But when the context or ownership is different, say the fraud team needs customer data one way and the billing team needs it another, it is often strategically better to just duplicate the Kafka topic or the data model.
So the trade-off is a little more storage for a lot more resilience.
Exactly. It improves isolation, it reduces the blast radius. If the fraud team changes their logic, it doesn't break billing. It's about choosing isolation over purity.
Isolation over purity. I like that. Okay, so moving from data duplication to the data deluge of logging. Another massive source of cost and sprawl.
It absolutely is. And here the discipline has to be when to log and when to shut up. Just logging everything indiscriminately creates this vast, costly sea of low-value data.
And then you can't find anything when something actually breaks.
Precisely. It actively hurts root cause analysis. The solution is structured. Contextual logging from day one. Make every log a JSON object with clear key value pairs. This isn't just about saving storage. It lets you reduce query latency from minutes down to milliseconds.
Right. It maximizes observability while minimizing your vendor bill.
You got it.
That same focus on structure applies even to the basics, like SQL joins. For all the talk of data lakes, relational logic is still running the show for most analytics.
It is, and some simple best practices here are just so high leverage. We still see people defaulting to inner joins, which are basically filtered Cartesian products, when what they really need is a left join.
Yeah, and join order. That's a big one.
A huge one. If you have a n-to-1 relationship, like a giant fact table to a small dimension table, you have to put the smaller table first in the join order. It just makes the data distribution so much more efficient. Simple discipline that prevents so much downstream pain.
So discipline is key. Now let's talk about a major headache in modern lakehouses. Schema evolution. How do we stop our pipelines from breaking every time the source data changes?
Yeah, this is where something like the chameleon architecture comes in. It's basically about using tools like Apache Hudi that have native schema evolution built right in.
Yeah.
Historically, adding a column or changing a type meant downtime or a massive data rebuild.
The total nightmare.
Right. But here you can get seamless column additions, type changes, whatever, with no interruption. Hudi just reconciles the schemas on the fly. If it sees an old file without a new column, it just maintains backward compatibility by injecting nulls. It keeps the whole system agile.
That agility is non-negotiable as we head into our final segment. The AI agentic revolution. I mean, all the systems we just discussed, the fast Kafka, the tuned Spark, they're the engine for this new era.
They're the foundation.
And the strategic signals are everywhere. I mean, look at the reported $11 billion IBM acquisition of Confluent. That tells you everything you need to know about where the enterprise is headed.
It signals a massive architectural shift. IBM is buying Confluent to build a unified smart data platform. The message is clear. Streaming native, low-latency infrastructure is no longer a nice-to-have. It's the essential backbone for enterprise generative AI. If your data is stale, your AI agents are blind.
And this rush to deploy agents leads straight to the next big problem, AI memory. Because right now, it's kind of the Wild West, isn't it? Just these unmanaged vector stores.
And that creates huge new security risks.
Like memory poisoning, right?
Right.
Where you can deliberately feed an agent bad data to corrupt its future decisions.
Yeah.
Or just uncontrolled privilege creep.
Exactly. AI agent memory has to be treated with the same seriousness as an enterprise database. It needs firewalls, access controls, row-level security, full auditability. The big takeaway is this. The database is the new memory firewall for AI.
We're already seeing huge wins when companies apply this kind of rigor. Take the Wix context engineering pipeline. They didn't just throw a giant LLM at their problem.
Yeah, they were smarter.
They built a deterministic pipeline in front of the model that normalized inputs and managed context retrieval.
Yeah.
And the results were just astounding. They cut the input tokens by 96%.
96%.
Which led to a 46% faster response time and a 23 times cost reduction per request. It'll let them use a cheaper model and still get better results.
It's efficiency winning the AI game, not just raw power. And the tools are catching up. Look at Apache Flink 2.2.0. It now has built-in ML Predict for LLM inference and vector search for similarity searches, right in the streaming layer.
So no more round trips to external services.
Exactly. And this tight integration is driving new industry standards. Pinterest's observability system is a perfect example.
Right.
They replaced a whole mess of fragmented tools with a single unified Model Context Protocol, or MCP, server. It gives their AI agents a single access point to these just massive data streams. We're talking 3 billion metrics a minute.
3 billion a minute.
7 terabytes of logs and traces a day. This unified view lets the agents perform autonomous correlation, find the root cause of issues faster, and lower their mean time to resolution. And what's really important is that they've donated this MCP to the new Agentic AI Foundation to create a vendor-neutral standard for connecting agents to tools and data.
That standardization is everything. And new tools are being built for this agent-first world.
Yeah.
Agentic Postgres, for example.
Yeah.
It adds things like sub-second, copy-on-write horking. They call it fluid storage.
Right. And native BM25 search alongside vector search, plus an integrated MCP server. It basically gives agents an instant, isolated sandbox to safely test and learn on production data without any risk.
And to bring it back to the data mesh idea, look at what BlaBlaCar built with their Data Copilot. It's an AI-driven IDE extension that lets software engineers do data analysis directly in their coding environment.
So they don't have to leave their workflow to go to a BI tool.
Exactly. It operationalizes governance right where the code is written and just speeds everything up.
Okay, let's try to wrap this up. If we had to crystallize this down to 3 main takeaways for everyone listening, what would they be?
I'd say number 1, massive cost optimization isn't just possible, it's mandatory now. You have to be challenging your assumptions, whether it's diskless Kafka or how you've configured S3.
2, architectural thinking is critical. Controlled duplication can be better than fragile abstraction, and disciplined, structured logging is vital for your budget and your sanity.
And 3, the database is the new memory firewall for your AI agents. As they become core to your operations, their memory has to be governed with the same strict controls as all your other enterprise data.
That's a perfect summary.
You know, a final thought on this, on the efficiency and architecture side, is orchestration. We're seeing this big push towards state-aware orchestration, only running pipelines when new data actually arrives. And for huge companies with thousands of models, that's crucial. But it's also important to remember, if you have reliable sources and good incremental models, sometimes good old-fashioned scheduled orchestration is perfectly fine and a lot less complex.
Don't over-engineer it if you don't have to.
Exactly.
That's a perfect note to end on. So, a final thought for all of you to take with you. If a 94% cost reduction is possible on a component as central as Kafka, where else in your stack are you paying for physical resources you might not need, and what foundational assumptions should you be challenging tomorrow morning? Go challenge them. We'll see you next time.
Spoken Tech for your ears.